In this series of conversations, we'll be discussing the impact of our global food systems and lifestyles with guests to bring a deep understanding of the challenges facing our society and creative ideas on how to address them. I'm Ash Sweeting, and welcome to the Ash Cloud. Today we are joined by Liz Head, a neuroscientist at the University of California, Irvine, who has been studying how diet and lifestyle impact cognitive decline across species. Liz, thank you so very much for joining me today.
My pleasure to be here. Thank you for inviting me.
So I'd like to dig into cellular health and its effect on cognitive function. So it's for many people, I guess it's a relatively new concept. So would you like to just outline, cellular health and cognitive function and how they're connected?
Sure. I guess one way to look at it is, the cells in our brains, neurons, we're born with them and they stay with us for entire lives, right? So as a consequence, our cells in our brains have come up with ways to deal with constant pressures of aging, environmental exposures, and how to maintain metabolism against, accumulating pathology that happens with normal aging. And the powerhouse of the cell is the mitochondria. By virtue of it doing its business of producing energy for us, it causes oxidative damage to itself and to the cell. And then there's all these other metabolites in there and enzymes that correct that damage and keep those cells operating normally or as normally as possible. So, there's a very tight link between how well our mitochondria function, how much oxidative damage they're producing, and how well we can compensate for that. And when we have imbalances, then those neurons, those cells in the brain, can't talk to each other well. And when cells don't talk to each other well in the brain, that means that your ability to remember and learn things also starts to slow down and potentially could fail depending on how significant the problem is.
Okay, so there's quite a few things there. One, you've got the need to maintain that mitochondrial function, and if there's anything that is needed to nurture or feed that. And secondly, you've got the side of things with the undesirable compounds that you mentioned. And once again, are there other things that stimulate high concentrations of those, or ways that can be managed?
So there's lots of compounds in our diets that normally help us deal with that mitochondrial stress and oxidative stress. And our lifestyles can promote that, or also, help our brain compensate better. So as an example, physical exercise, right? Causes a lot of glucose to be circulated in your brain, which is great for your brain. Your brain loves this. It helps, support healthy neuron functioning. But by virtue of being more active, they're producing more energy and they're making more oxidative stress. So exercise is really good for your brain. It actually increases oxidative stress, but that's a good response. Believe it or not, it's kind of a two-edged sword. That some stress is good for your brain. Too much stress or chronic stress is bad, because that's where your compensation starts to break down, and then other things start to kick in, like inflammation. So the best way to kind of keep your mitochondria happy is, one of the major things is a good diet. A good diet is critical for your mitochondria. Vitamins E and C are all really important for your mitochondria. There's other nutrients you get from fruits and veggies. Antioxidants, naturally occurring antioxidants, are great for your mitochondria. And that little bit of stress of getting good exercise and stimulating your brain through other activities is also good for them. They grow, they have lifespans, mitochondria. Imagine within the cell, there's mitochondria that are being born, they're dying, they're being turned over. So there's a whole little mini lifespan going on inside your cells.
Excellent. And I imagine there's a lot of similarities between us and our furry friends, be they dogs or cats, in this regard.
Oxidative stress is one of the, and mitochondrial dysfunction are some of the most universal aging changes that happen across every species that has been examined. It's a universal truth that oxidative stress is a big part of normal function and aging. So, so it's not unreasonable to expect that whatever we do as humans for our mitochondria and to reduce oxidative stress, the same things will apply for dogs and cats and whales and, et cetera, et cetera. So it's kind of nice research-wise, because whatever we learn about dogs applies probably to humans, and whatever we learn about humans will apply to, say, dogs and cats. And another kind of universal truth about oxidative stress and mitochondria is it increases with age across every single species. And when you think about diseases like Alzheimer's disease, the biggest risk factor for Alzheimer's disease is age,
Yeah.
of which this is a big piece.
And where does the inflammation sit in there? And I guess anything, and people have heard about senescent cells and how they link into inflammation. And from my understanding, senescent cells are vital for part of the immune response. But if you have too many of them, then you have all the secondary all the metabolites that they produce, which need detoxification, etc. So how does that fit in with the mitochondrial story?
It's kind of a vicious circle. Again, just like oxidative stress, inflammation, a certain amount of inflammation is healthy. It helps stimulate a different kind of cell in your brain to go around cleaning up stuff like senescent cells or dead cells. They also go around helping neurons reconnect if a connection between neurons isn't really necessary anymore. These inflammatory cells help clear that stuff out so that new connections can be made. So inflammation, oxidative stress are actually in many ways good things. It's the chronic high levels that become a problem. So if you have neurons in your brain that are dysfunctional because they can't metabolize properly because their mitochondria are breaking, they're going to die, and these inflammatory cells are going to come in and try to clear it up. What they do is, in response to cues that something needs to be eaten up and degraded, they release a whole bunch of chemicals, which are inflammatory, to pull more of their friends over to help clear this material. So where one cell, for example, microglia, I mentioned these are our major immune cells in the brain. They see a point of damage, something that needs some, degradation, and they'll call out to all their little friends to come over and help. And then what you end up with is a cluster of these cells secreting chemicals that are inflammatory. So there's also compensatory mechanisms. There's feedback, they shut down, they go quiet, or they may die because they try to take something up and they can't degrade it. And then there's this really interesting interaction with the periphery, what's going on in your blood and your other tissues, because the chemicals being released in your blood from inflammation from other parts of your body can get into your brain and cause problems as well. And this is where a lot of really fascinating work in the microbiome is giving us new ideas about how the guts, inflammation in the gut from food or imbalances in nutrients can affect your brain. So it's a really exciting time research-wise. These links are just fascinating.
That is absolutely fascinating. I would not be surprised, so you could confirm this, that by having this activity from these inflammation-causing cells that are doing good work, that's actually putting extra demands on the mitochondria and their need to supply energy. So it's the cleanups coming in there, but it also makes it busier for the mitochondria. So you have a balance between those two things.
Right, and microglial cells have mitochondria in them too, right? So you can just imagine these little flares of oxidative stress is getting high, and the inflammatory markers are getting released, and then there's this calm down phase that is normal, and that's what you want to have happen. But if you have a disease process or an aging process, some of those things might be slower. So inflammation is hanging out there longer. Or in the case of a disease, it doesn't get resolved at all, it gets worse. So it's a good target.
You've moved from these small bits of necessary stress to clean up the problem to this much more chronic situation,
right,
which then is basically putting demands on those neurons from all angles.
Exactly, because so it becomes a vicious circle. If those kind of corrective responses or compensatory responses are, there's machinery here in our brains that's used to dealing with this, and it will change function to calm down. And if that breaks, then you get this real problem that's really hard to stop.
That's amazing. And I guess the dynamics of biology just to continue to open up new doors and new windows into more amazing stuff. So thank you for that. With back to what you're saying about the connection to the microbiome or the diet or to exercise, and this goes both for your pets and also for humans, what can be done to, I guess, make it as easy for our bodies to cope with these issues and delay the onset of age-related issues?
I don't know if we know the whole answer yet. There's some really fabulous labs looking at that exact question. And, the idea being, is there some way we can modify our lifestyle to give our bodies and brains lots of mechanisms to protect ourselves? And with the microbiome story kind of evolving over time, this obviously relates to your diet. And, what is a healthy diet to promote a healthy microbiome that in turn reduces inflammation in your body and then in turn reduces inflammation in your brain. So, and it's a very complicated field, and there's a lot of methodologies that are being discussed and how to standardize measuring all these things. And I have no doubt in the future if there's not already clinical trials trying to, modify specific parts of the microbiome to see if they'll impact the brain and also then improve cognition. And there's no reason why the same things would not be in play for dogs and cats and goats and sheep and all of them.
Fascinating. And I guess, is it wrong to extrapolate that if you've got a diet that is inflammatory because it's not just right for you or your microbiome's being inflamed by your diet, then those inflammatory metabolites, etc., will actually start to impact your cognitive function?
Right, that's exactly it. And that might be very individual. So what one person's healthy microbiome is for them and their brain might be different from another person. And, this brings about this whole idea of precision medicine or individualized medicine. And again, same for dogs and cats. No reason it should be different. To understand better what place that person's microbiome is and whether specific kinds of diets might benefit them more than others. I know there's a lot of talk about anti-inflammation diets, and there's a lot of really interesting stuff out there. I'm not sure if there's been kind of the definitive clinical trials to really show that an anti-inflammatory diet really does help your brain. There's a lot of small studies out there and studies in animal models. So that'll be a fascinating thing to watch. And I do suspect, though, not everybody is going to respond the same way.
There, on that note, there was a fascinating study I saw the results of not too long ago about insulin response to two different diets. And one was they people ate some ice cream and they insulin response. You may be aware of this study. The other one, they fed people some sushi and measured the insulin response. And they found that a certain number of people, percentage of people, roughly quite similar, they had the spike from the sushi and some people had the spike from the ice cream and vice versa. And the conclusion was all back down to the microbiome.
It's entirely possible. It makes a lot of sense, doesn't it? And depending on the place your microbiome's at, ice cream might be a bad thing or it's not an issue.
And that would be the same for what you fed your animals as well, in terms of what was right for their microbiome and what was that, which would be individual to that individual animal.
Yep. And, also given the fact that I certainly can speak for my dog, Benny, he gets little treats of human food. I don't know how similar his microbiome might be similar to the rest of us in the house, which is kind of fun to think about.
That's fascinating. What about when it comes to metabolic disease and the inflammation caused by metabolic disease? And obviously this affects both pets as well as humans as well. How does that translate to cellular health within and cognitive function within the brain?
I would imagine that with metabolic disease, we are talking about a system where there's going to be way more inflammation. And so if, for example, untreated diabetes is a metabolic disease, it does definitely impact your brain. It puts you at higher risk for Alzheimer's disease. Whether it's going through all these mechanisms, I'm sure there's beautiful work out there showing that it does. That inflammation, again, in your periphery from your metabolic disease is impacting similar pathways in your brain. So this is why when we're thinking about Alzheimer's and healthy aging on a cellular level, any kind of risk factor we can control, like hypertension, like metabolic disease, those all help your brain stay healthier and protect you from the aging process and from disease, hopefully, in the long run. So there's definitely a tight link, and it's that whole area is also really blooming.
Given what you said about the vicious circle and the cascading effects, is it wrong to conclude that the earlier or the longer you can delay the actual start of that vicious circle, the easier it'll be to keep those levels of inflammation and keep that mitochondrial function up, so the brain is working as optimally as it ever has?
That is 100% accurate. I think if anything we're learning in this whole field of aging and Alzheimer's disease, for example, prevention is going to be the key. And how you prevent it is going to be not a single bullet thing. It's not going to be, I just need to take a lot of vitamin E or eat a lot of oranges or, run 2 miles a day kind of thing. It's going to be multifaceted. It's because your body's complex, so is your brain. There's lots of things that are impinging, and we all have different abilities, again, to kind of correct, prevent, compensate. So the earlier you adopt a lot of healthy behaviors, including good diet, exercise, good social activity, you're giving your body and your brain all kinds of ways to deal with damage that maybe will be inevitable, but you could stave it off longer, or you give your brain and your body the tools to fight it longer. So if you think about, if we always have our own personal trajectory that, say, for me, example, at 75, I'm going to develop Alzheimer's disease, but I've had this really healthy lifestyle all along, maybe I'm going to push my curve out to 95, right? So what we're talking about is health span. We're trying to stay healthy as long as possible. So definitely prevention is the key. And this is why certainly in the Alzheimer's world, and I think what you're seeing with some of these big, beautiful aging studies in dogs that are going on, which I love watching, understanding what are those co-occurring illnesses or other health risk factors are putting you at risk for unhealthy brain aging. The more we learn about what those are, the more we can start controlling them.
And is there a time that, a trigger point where you should say, okay, this needs to be taken more seriously, and be that for ourselves, middle age-ish, whatever that is these days in the 40s, or for a dog, middle age-ish, say 5 or 6, or is it just you should start from day one? Or how does that, I guess the cost benefit of jumping in and taking steps to maintain your cognitive function and
I think it's always easier to have something going as early as possible. Trying to change a lifestyle, a big one, for example, in middle age is tricky and hard for dogs and for us. So, I think if we're going to consider how well can people stick with a program of a healthy lifestyle, the sooner you start on it, the better. And if you have to transition in middle age, if suddenly you develop hypertension in middle age, it's like, get on it. Just get on it ASAP, treat it, control it. Hypertension, for example, is just one of the biggest things that gives you risk for all kinds of unhealthy brain aging, let alone your heart. So we have lots of things we can manage really well, and they won't show up until you reach a certain age, right? So just those regular visits for dogs and humans and blood work and blood pressure and all that good stuff, those are low-hanging fruit things that we can manage.
So in some ways, is it wrong to assume that once you've actually developed, be that your pet or yourself, developed those clinical symptoms, in some ways the ship's already sailed because there's already been damage? It's not too late to change things, but you've passed the optimal time for prevention.
I see. So there are situations like that, but here's where you're going to find out I'm an optimist.
I love optimists, by the way.
So for example, mild cognitive impairment is thought to be one of the earliest signs of progression to Alzheimer's disease. There's even an earlier change that people are really working on or trying to understand now called subjective memory complaints, where it feels like my memory's going, even though if I do a test, it doesn't show it. Okay. So when a person already has mild cognitive impairment, they typically have a lot of the Alzheimer changes in their brains already. So here's where my optimistic part goes, that if you can find ways to help your brain compensate for that damage, to make your neurons healthier so they can keep absorbing damage and functioning, those things will work for a period of time and keep you healthy for a period of time. Ultimately, in a disease process, that's going to crash until we figure out how to treat the actual disease itself. But let's say we have a normal aging person, what we would call normal.
Yeah.
And we all slow down. Our brains start to chug a little bit. We get there. We're just as smart as before usually, but it just takes us a little longer and we get a little more forgetful maybe. So anything we can do to keep our brains, just empower our brains to deal with that damage is going to be good. So my optimistic view is, even if you think you're struggling or things are changing, and you can go ahead and deal with all these other co-occurring illnesses, like, we talked about diabetes, hypertension, you have a lot of opportunity yet to improve.
And obviously we can go to the doctor ourselves. We can have our friends give us or family or loved ones give us feedback about maybe we're getting forgetful. How would you monitor signs in pets that their cognitive function is potentially slipping?
That's a really good question. So there is a canine cognitive dysfunction syndrome, which is, a lot of us kind of think of it as almost more like a mild cognitive impairment version in dogs, and they can kind of creep into the real dementia area where they're really not functioning well. They've really lost their ability to signal to go out. They don't remember people, so all of those things apply for dogs as well. And what we've learned with research in dogs, again, the earlier you start interventions to promote their healthy brain aging, the better they do in the long run. So the way we detect this in clinic, and I'm not a clinician, I'm a basic science researcher, I use tests in a laboratory setting that are food reward motivated. My dogs love to do this work for me, and I can really directly ask how well they're remembering things and how well they're learning things. So I can get numbers, just like we go into a clinic, get a neuropsychological test, we get a number that says you are in the normal range or you are not performing as well as people around your age. And I can do that for dogs in this research setting. In the clinical setting, pet dogs, usually, I'd like to hear that veterinarians are asking owners about changes in behavior that might signal a problem. And there's specific kinds of behaviors that change with aging and could signal this change into impairment that that the veterinarian can query the owner about. There's also survey tools, questionnaires. They're online. Some of the pet food companies have them online. You can actually do a test on your own dog and get an understanding. And you really need to look for change over time. So a single time-based, yes, my dog circles. Yes, my dog's up at night. There's incontinence randomly. Well, your dog might have always been like that. right? So then you go back a year later and you fill out that questionnaire again, and you're looking for something getting worse. And that is a good signal that something's happening. And if you can eliminate its other causes, like kidney disease, for example, blindness, deafness, then you know something's going on in the brain. And so that's how we diagnose this in our pets, is that change over time in specific kinds of behaviors that can't be explained by systemic disease.
And they work the same way as we do in terms of the value of exercise, the value of sleep, the value, not that many dogs have trouble sleeping.
No, not mine.
The value of a healthy diet, and managing inflammation across the body.
Yeah, there's some beautiful published research where different groups, including our group, has looked at the impact of an antioxidant diet, for example. We studied that in depth, and it's remarkable how good an antioxidant diet will help brain function in dogs. And that's kind of an interesting story, because back when we started doing this work, it was in the late 90s, a long time ago now, I'm aging myself. When we started our first antioxidant enriched diet for dogs to test if this would improve their ability to learn and remember when they're older, it turned out the existing senior dog diets were deficient. So our study actually didn't necessarily look at the effect of improving antioxidants for dogs. It actually brought them to normal levels where they should have been, and it had a huge impact. And now all the diets you can see all have antioxidants, and they proclaim, it's anti-inflammatory, antioxidant, and that was because the diets before were actually deficient. So beautiful evidence that benefits the brain, and they directly improve mitochondrial function, reduce oxidative stress. And more recent work that we've done suggests it improves the health of the blood vessels in the brain. So there's lots of positive benefits of an antioxidant diet for dogs, and that's got to be good for your brain too as a person. So I'm not saying eat the dog kibble, but nonetheless, eat lots of fruits and veggies. The supplements are never as good as food, ever. And then we've also looked at the impact of enrichment. And in our words, that enrichment meant they went for walks 3 times a week. They had toys in their kennels that got rotated, so they had lots of new toys to play with. They were housed with a kennel mate, so we socially enriched them. But then we also took them to school, so we taught them new things that had a huge impact on their ability to learn and remember. But what was absolutely fascinating to me, and this is why I'm an optimist, is later when we looked at the brains of these animals, when they had finished participating in this study, we found that we hadn't changed any of the Alzheimer pathologies. They still had kind of the Alzheimer changes in their brains, but they were functioning way better than a dog that didn't get any of those lifestyle changes. So it means we gave their brains the ability to compensate and fight the damage that was growing. And that's why I'm an optimist for us, because even if we have some Alzheimer changes in our brains, if we make these changes in lifestyle, we'll give our neurons more power to fight for a longer period of time. So there's great data in the literature that antioxidant diets, ones that really improve mitochondrial function, all these, benefits to exercise, social function, cognitive training really work for different reasons, which is why putting it all together, you're hitting multiple pathways in your brain to help it in 1,000 different ways that a single drug could probably never do. So it's really cool. It's really cool stuff.
That is absolutely wonderful. And it's great to hear the way that how you study both dogs and humans. You've got the fact that it's much easier for us to control our dog's diet than it might be to control our own diet, because we're not tempted in the same way.
Right.
Exercise, well, I guess the dog's possibly going to be a driver of exercise for both of us. Dogs live in the same environment, so they're exposed to the same roadside pollutants or household chemicals or air conditioning systems or whatever it happens to be. And then we've got the advantage from a human perspective that they live for 10, 12 years instead of 80 odd years. So we don't have to wait as long to get some results.
True that. Yep. And I always thought it would be fun to consider that if you do all these activities with your dog, right? Going out for walks, hanging out, playing, training on new tricks, you're helping both each other. Like, it's good for you, it's good for your dog. It's a win-win.
Where, in terms of there's directly feeding the mitochondria, things like the NAD boosters, etc. And also back to the senescent cells, there are naturally occurring compounds that actually will help to, I guess, manage senescent cell populations or numbers. How do you see, have you looked at those, and how do you see them fitting into the picture?
Yeah, we did, and actually one study we did, we translated to people. So one of the compounds we looked at, and when we built this antioxidant diet, we had vitamin E, fruits and veggies added in, but we also included lipoic acid and acetylcarnitine, which are specific mitochondrial compounds that improve the health of mitochondria. And it was that combination diet that had such a huge impact on how well their brains worked. Subsequently, when we tried to figure out if it was the key to the success of this whole food was because of the mitochondrial piece of it, or was it the cellular antioxidants that really helped, we weren't able to get as big effect. It really was the combination that had the biggest effect. So, so my philosophy in a lot of these things is that any single target, like, lipoic acid, for example, taking a lipoic acid supplement is probably, in the long run, not the best way to go. You really want to capture everything to hit multiple targets in your mitochondria, multiple targets in your cells that benefit them both. So, but I'm sure there's, again, there's probably other groups that are interested in this, are going to be looking at this for dogs and cats. And there's lots of anti-inflammatory diets I've seen in the pet food stores. And so I know there's some basic clinical data out there that those companies have done to see if it has a benefit. So it's just terrific. So the supplements, the targets, there's always less impact. So the example of the lipoic acid acetylcarnitine study we did in our dogs, we took that same essential formula and looked to see if we could improve cognition in older people with Down syndrome who have dementia. And there's a whole backstory on that I won't go into, but it had very little impact at all. Even though people did take the cocktail that we created, it just, either it was too late in the disease process, we couldn't bring them back, or just hitting those little targets was not enough compared to all the targets we were hitting with our food. So that's kind of my philosophy on it, is I don't think taking extra vitamin C or vitamin E or lipoic acid are going to hit, but I do see a lot of medical food cocktails that are essentially in one pill trying to combine all these things. And I think the discerning person should look very carefully at the data they present to understand if it's really helpful or not. What we're really trying to do is improve the function of our immune cells in our brains. So I talked about microglia. There's another kind of cell, astrocytes, that are part of, that can generate a lot of inflammation in the brain. So we're looking at a drug that's already approved for people to see if we can apply it in a different way in the context of aging and Alzheimer's disease, and see if it has benefits for dogs. And then by extension, can we do this in people? So, so we're having, it's been, I'm really excited because we've done a lot of different kinds of treatments for dogs to try to make them, cognitively better. And we've had a lot of failures. It's really hard to move learning and memory ability in people and in dogs. And this latest research we have, and there'll be some more papers coming out on it soon, we're seeing a cognitive benefit. And actually what we're seeing is we started our treatment in middle-aged dogs. It's our first prevention study. And we're now starting to see that our untreated dogs are getting progressively worse with cognition, and our treated dogs are staying stable. And I think that is fabulous. So I'm excited because it's potentially going to help all of our dogs.
Except that by middle age, you're talking about 50%, the 50% mark, because obviously a big dog, that's going to be 5 or 6 years, and a smaller dog, it could be
right. So the way that we ended up, we have a little bit of a spread with the ages that we started, and these are beagles. So we started dogs between 4 and 7 was our starting age range, and we're watching them. Then they will have been on study for almost 5 years when we finish. So they're definitely getting into that age range, which 8, 9 for beagles, where you start to see a lot of Alzheimer's changes in the brain. So, but yes, that will be completely different for an English Mastiff. That's then you want to go like to 2 to 3 years, for example. That's where their whole lifespan falls, right? So, and that's always the tricky part about dogs. When I say middle age, it means a different thing for every breed and size of dog. It's more related to size of dog.
Yeah, well, the dog is an amazing. It's because I don't know of any other species where you can have a fully grown adult that maybe, say, less than 10 pounds, and you might have a fully grown adult in the same species that could be close to 200 pounds.
200 pounds, yep. Yes, and dogs break all the rules, right? Because in nature, the bigger animals live longer.
Yeah.
Right. In dogs, it's the opposite. So very cool genetics. Mm-hmm.
Yeah, amazing. So just is there anything else that about aging, cognitive decline, health, nutrition, metabolic disease, the microbiome that you think we've missed that you'd like to add?
I think we've had a lot of fun talking about this. I think it's just pretty clear that the more things you can stay on top of with lifestyle, good lifestyle, the better your chances your brain has to fight some maybe disease that's going to come eventually, you know. And I think you also can see I'm a real optimist when it comes to all these things. You know, I think the kinds of interventions and lifestyle changes we're talking about are typically not associated with side effects. So there's no harm in doing these things, right? So, yeah, we'll see what the future holds. It's data just keep pouring out and all kinds of new things every day. There's something new. Yeah.
If there are side effects, they're all positive side effects rather than
good point. Very, very good point. Yes, absolutely. Mm-hmm.
Wonderful. Well, thank you so very, very much.
My pleasure, Ash. It was nice to talk to you.
You've been listening to The Ash Cloud with me, Ash Sweeting, in conversation with Liz Head from the University of California, Irvine, recorded in California in September 2022.